All right, so in number 8, we're giving this fourth degree polynomial that we're going to have to do a bunch of stuff to. Let's identify what we can right now. We're going to have to do rational roots theorem on it, so it's going to take us a few minutes. But there's a couple of things we can already figure out. For example, I can figure out that it's a fourth degree, and I can figure out the leading coefficient is 1, and end behavior is first and second. Zeros I'll get once we figure out the factored form. Y-intercept I can do though. Y-intercept, if I put 0 in, hopefully we get a 4 out of that. So 0, 4. Okay. The rest of this information we need to wait until we actually figured out factored form on us. So let's go through rational roots theorem, and just observation on the actual test. That's about as much space as I'm going to give you, but I understand you're going to need more space. So that speech I gave at the start of class about taking out some scratch paper, this is definitely a question that I think scratch paper would be appropriate for. I don't expect you to do it in that little tiny space. I am not that mean and cruel. So on my scratch paper, here we go. I wrote it out myself, sort of. All right, so I want to look at the last number and the first number. So the last number, I want to make a list of all the factors that go into it. So 1 and 4, and then 2 times 2, 2 and 2, so just that. The first number, the leading coefficient being 1, just has the number 1. So possible roots are 1 over 1, 4 over 1, 2 over 1. So it's plus or minus 1, 2, and 4. So there are 6 possibilities. Then I want to take just a brief second, because we know about Descartes' rule of sign. Let's try to apply that real quick. So positive to negative, that's negative, negative to positive. All right, so as far as positive roots, there are 2 or 0 positive roots. It's iffy on the usefulness of that. However, negative x, let's do that. And let's just talk about if the sign would change or not. So if I evaluate each of these terms with a negative, would x to the 4th change? Nope. It would still say x to the 4th. X cubed would change signs. X squared would stay the same. 4x would actually switch to a negative, and then plus 4 would stay the same. Okay, so this is on the negative side. There's positive and there's negative. Okay, so that tells us we have 2 or 0 negative roots. Okay, so was Descartes helpful? It's iffy. Is there any reason why I'd pick positives over negatives? Nope. I'm still randomly guessing, simply because I don't have any indicator, but maybe upper-lower bound theorem will kind of save me a little bit of headache on that. So let me make a list of my coefficients. X cubed, x to the 4th, x cubed, x squared, x, and constant. 1, negative 2, negative 3, 4, and 4. And let's start with, let's start with 1. Might as well stick with positives here. Alright, so we'll drop the 1, multiply, okay. Then multiply gives me negative 1. That gives me negative 4. That's negative 4. That's 0. Well, that's 0 and that's 4. So 1 did not pan out. Now, the nice part is, it's sort of nice because it's not really going to change what we do next, but if I think about upper limits theorem, I plugged in a positive 1. The only thing that a positive 1 can say is whether it's an upper bound or not an upper bound. And because this row of numbers were not all positives, so for upper bound it's got to be all the same positive sign. Sorry, positives, no negatives can show up. So negative showed up, so that means 1 is not an upper bound, which means another number is further on the number line, so it's okay to go to 2. Honestly, if we hadn't had this conversation, we'd still go to 2. So we're going to try that next. Alright, so we'll drop the 1. Multiply. Let's see, -3. So -6 gives me -2, -4, gives me 0. Okay, so we got 2 to work, yay. So kind of keep track of this. So that would be x minus 2 in its factored form. And then the part that's left, that translates to x cubed minus 3x minus 2 is what we're now left with. Okay, so let's check for multiplicity. So if we drop the 1, multiply, I get 2, do that, get 4, gives me 1, gives me a 2, gives me a 0. Okay, so we did have a multiplicity there of a 2. Okay, so that's x minus 2 squared. Okay, and so this translates into x squared minus 2x, plus 2x plus 1. And then we'll just factor that, which is actually x plus 1. It's actually x plus 1 times x plus 1. Okay, so it's x plus 1 squared, so there's another multiplicity there. And as far as our Descartes goes, we said that there would be 2 positives or 2 negatives, and we got 1 of each. Okay, so let's take this, put this back on the other side. So x minus 2, x plus 1. Oh, you didn't want to see behind the surface there. Minus 2 plus 1. Okay, so x minus 2 squared, x plus 1 squared. And note the multiplicity. So it crosses at 2, 0. There's a multiplicity of 2. And at negative 1, 0 with a multiplicity of 2. And there's my lovely repeated question that got to work on that. Okay, so let's plot points then. Goes through 0, 4, goes through 2, 0, negative 1, 0. It's going to go up the quadrants there. That's a bounce, and that's a bounce. Alright, so we'll kind of connect this with a smooth curve. So it looks like a W. It's pretty much what it looks like. Alright, number 9, we're going to just practice another one of these rational roots theorem ones. We got some information we can fill out now, then we got to go figure out how to factor it, then we'll come back and fill in the rest. Alright, so let's talk about degree. It is clearly a cubic. Leading coefficient in this time is 2. End behavior would be first and third. Possibles we can figure out real quick. If I look at the last number and the first number. Alright, so 4 is a 1, let's see, 1 and 4, and then 2 and 2. So 1, 2, and 4. The first number is a 2, so that's a 1 and a 2. Alright, so I'll put my little plus minus. Put the 1, 2, and 4 all over 1, so I get the original list. Alright, then we're going to go back and do the same 3 numbers over 2 and pick up anything new. So 1 over 2, that's a new choice. 2 over 2 is not, because that's 1. 4 over 2 is not, because that's 2. Okay, so we only picked up a half on that case. All right, and y-intercept. So if we go back in and plug zeros in for x, we should end up with 4 at the end. So 0, 4. And now I need to go in and factor it. So let me come over to my little scratch paper here. We already made our list of possibles. It's plus or minus 1, 2, 4 and a half. Let's use our Descartes and see if that gives us any sort of hint. So positive to negative, negative to positive. Okay, so we get 2 or 0 positive roots. Okay. Let's look at f of negative x. See if that does anything for us. If I put a negative in for a cubic, that actually changes the sign. If I square it, that doesn't change the sign. That keeps it the same. Put it in for x, it does change the sign. Alright, and what does that tell us? Negative, 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 right there. So I have 1 negative root. Alright, well, so if I'm going to guess numbers, I'm probably going to hang out more with the positive side of things than the negative, since I have only one negative solution. Alright, so let me make my list of x cubed, x squared, x, and constant. So 2, negative 7, 4, and 1. Alright, let's try 1. Off to the side there. Alright, drop the 2. Multiply, I get 2, so that's negative 5. Multiply, it's negative 1. Multiply, and I get 3. Okay, so 1 did not work. Moreover, 1 is not a bound, because I don't have all positive numbers there, so that means keep going on the number line. So we're going to go to 2. Alright, so drop the 2, multiply, gives me negative 3, multiply, gives me negative 2, oh, sorry, negative 4, and yay, I got it. So one of our roots happens to be 2, so we'll kind of keep track of this. So it's x minus 2 in factored form. And this translates to be 2x squared minus 3x minus 2. And now that it's down to a quadratic, we're going to factor it. So 2x and x, and I'm thinking let's put the 2 there and the 1 there. Let's see, 2x times that gives me a negative 4 and a positive 1, so we'll make that negative and that positive. Okay. So let's put that with the other, so we have another multiplicity. Okay, so let's go back to our blank. So it's x minus 2 squared and 2x plus 1. Okay, so x minus 2 squared and 2x plus 1. Zeros then. 2, 0 with a multiplicity of 2. And the other one would be negative a half 0. Oops, negative 1/2 0. Okay. And, alright, so let's plot what we know. I know it goes through 0, 4, 2, 0, and negative 1/2 right there. And I know it goes through first and third friend behavior. At the 2, 0, there's a bounce. I know it's got to cross there. I know it's got to wiggle through there. Alright, so let's connect our graph in a smooth, continuous fashion. So cross, curve around, and bounce. So our graph looks about like that.